Wah, awal masuk.
Tak nak lewat mencari tu.
Akak dah share dengan diorang, tapi cikgu akak cakap sikit lah nak cakap akak dah upload kat diorang data tu, yang Hakim share tadi tu.
Ya.
Lambat sikit hari ni sebab ada kelas habis pukul 11. Sekejap lagi kelas sekarang pula.
Oh, okey. Tak ada masalah.
Akak dah email, okey tak?
Terima kasih, tapi saya tak check lagi.
Oh.
Buat final preparation.
Oh, yelah. Akak tukar yang apa, bunyi bising tu akak tukar pada pemetaan hingar.
Oh. Dia memang hingar lah ke?
Oh, dia bunyi hingar.
Oi. Rancak pula saya punya WhatsApp ni. Subhanallah, apa ni? Oh, patut lah. Okey.
Song dah masuk. Morning Song, you just finish your class?
Yes, teacher.
Oh yeah.
Morning, I finished my class just now.
Oh, okay. So your time, take a deep breath before we start our class with Dr. Hakim today. Before that, I want to tell you that I have uploaded a file of Excel file of noise data in the e-learn for today's class. So you may download the data today if you want to do the noise map simultaneously while Dr. Hakim teach you on how to produce the noise map. Okay, I have uploaded it in the e-learn. I think because it's 11 now, okay, just wait another 3 to 4 minutes for Aiman. I think I will start record our session by now. Maybe Dr. Hakim would like to say something before the lesson start.
Yeah, thank you, Dr. Herni. So today what we are going to learn is regarding the data preparation, okay, on how to arrange the data and whatnot, and then followed by some brief introduction on the concept of coordinate system, and then we will start processing, which is uploading the data through ArcCatalog and ArcMap, then do some analysis, and finally we will produce a map out of it. So that is the 5 agenda of today short course. Yeah.
Okay, so that will be the lesson for today for everyone. For last class, I have uploaded the recorded video. Oh, I forgot to share the video with Dr. Hakim. I will share it later through email or maybe through WhatsApp. Let's see which one which apps able to to share the information and to share the long video because it's 1 hour and a half video. So I hope while waiting for Aiman, you have started to download the noise data that I've just uploaded in e-learn. And then you have started opening your ArcGIS software. If you have any problem, you let me know, or I will share. Dr. Hakim, can I share your phone number so that they can just message you in case they got problem?
Yeah, sure.
Alright, I will share Dr. Hakim's phone number so you can straight away message Dr. Hakim in case you've got problem with the production of the noise map later during your project progress. I am typing the phone number of Dr. Hakim in the chat box. So you may save this number, okay? That is the number of Dr. Hakim. I think we can begin the class, Dr. Hakim, then Aiman will join us later. Okay, the class is yours, Dr. Hakim. Thank you.
All
I will
right.
leave the class. I will leave the class this time. Oh, I cannot leave because I am recording it. Okay, I will just go on like this.
All right. Thank you very much, Dr. Herni. So now I'm going to share my screen. Yes. Is it? This is my screen, right? Okay.
Yes.
Yes. Okay. So let us begin. First of all, of course, we will start with the data preparation. So let's. I hope you guys have downloaded the data that I've given to you. All right. The data is actually in a tabulated form. Is already been in this form. So the thing is, let's say you obtain the data, the raw data, which is not as in this form. So the question is how to arrange the data. Okay, so there are certain rules in arranging the data. First, as you can see here, the starting from the number. Okay, this would be best if you name it as your point. Okay, not as number, because it will be very confusing later on when when we uploaded it into the ArcGIS. Then the next is to write it as like this: latitude and longitude. Please write it full: latitude and longitude, so that the system, so the ArcGIS will recognize this one. Okay, and arrange it to an appropriate coordinates arrangement. Okay, of course you will understand this better after this. And the next one is on writing the name, like so. Okay, although this is uh, uh, the best writing style of these of the names, but actually ArcGIS, it is hard for ArcGIS to understand this one. So what you need to do is simply write it again. I believe this one is L10, like so. You don't need to make it what's the term? Well, you don't need to make it hyperscript, like hyperscript, or like this one. So simply write it like so. Okay, L max. You don't have to use this format. Okay, this one is LEQ. All right, as simple as this one, like this. So these are the requirements on the data preparation, apart from arranging the data like this. Okay, so the next is to remove this border. Of course, we don't need any border, and we don't need any bold text. Okay, all right, so this is the best way to arrange the data. Okay, please, if I'm going too fast, please tell me. Okay, um okay, once you have prepare and arrange the data like this, next what you need to do is to save this file. Okay, you can either save it like so, just save it, or later if we have trouble uploading this data, okay, as in this latest latest version of Microsoft Excel, you can always save the data like this. Go to save as and change the format from this recent Excel format, XLSX, to this one, 97 until 2003 version, XLS, or the CSV. So there are three format that you can save this file. Okay, so it depends. Sometimes things happen, sometimes it cannot be uploaded. So don't panic, just go back to your Excel data and then change the version. Okay, alright, as in this case we just go with this recent Microsoft Excel version, and we just take a look whether it is okay or not. Alright, well, that is for the data arrangement. I hope you guys understand it, because we are going to proceed with the next agenda, the coordinate system, a brief understanding of a coordinate system. Alright, and then you need to close it, or you will not able to upload the data into the ArcGIS. You need to close the Microsoft Excel. Alright, regarding the coordinate system, I have some pictures here. So this is the Earth as we all know it. Okay, of course, it is globe. It is what we call this in a form of sphere. All right. So this actually we call it as a 3D geographic projection. All right. This is the most accurate projection of to represent a coordinates. All right. But it is hard to model, to create a model or to make a measurement that is understandable for us. That's why the GIS analyst actually produces a new form of map representation, which is like this. So this is one of the projections that is widely used. All right, this is called as a Mercator projection. All right, if I'm not mistaken, it is created by a pope named Mercator, if I'm not mistaken. So this is the kind of map that we used to look at. All right, it is easy to zoom in. You don't have to have a 3D software in order to view this one. Okay, it is just like a normal image, which is in a 2D projections, two-dimensional projections. Okay, but this type of projections is actually inaccurate. All right, it only accurate in this part of, in the middle section of the Earth. When you go to the north or to the south, the representations will be very wrong. Okay, as we can take a look at this. The Russia or China here is not as big as it looks in this projection. Is actually much smaller, okay, as compared to Africa here, Africa continent, or the South America here. It's actually not as big as like this. Okay, but due to the projections, due to understandable communications between one another, it is better to have a projection compared to this type of projections or this type of display. Okay, this type of display is in a form of computer is also very recent, uh, um, through the what we call this a Google Earth. All right, through Google Earth you are able to view everything in a form of globe. All right, so okay, to understand even further, let's take a look at this actor, Superman. um this is what is called as 3D projections. Okay, where you can see the shape of his face. All right, and how it looks like, because it's familiar with us. Okay, we see this kind of face, but uh, if we project this face, if we flatten out this face, it will looks like this, which is hard to recognize whether this is the Superman actor or other other person. So this is what I trying to explain here. The correct measurement is through this 3D type of projections, geographic projections, as compared to this one. But this one is more familiar to us. Okay. Similarly, as this one is uh, is a correct projection of the face, the our face. But this is if we flatten out the face of the actor in order to, I don't know, to make measurements or to upload it in a computerized form. All right, let's not go deeper into coordinate system because it will make you all confused. But things to remember that this one will be measured in the metric unit. Okay, metric unit, kilometers, meters, centimeters. All right, if you want to measure in terms of metric units, yes, you need to project the 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 face of the earth. As compared to this one, you will not able to measure in meters. Instead, you will measure it in latitude and longitude. So latitude and longitude, it sounds familiar, right? So latitude and longitude is the coordinate system that we just arranged right here. Okay, this one, latitude and longitude. Okay, next, how to obtain, the question is how to obtain the coordinates. Okay, as you can see here, the provided data is actually just 4 decimal places. Yeah, 5.1444, which is not as accurate as or not so suitable for your studies, because all right, this is I want to talk about this, because for the latitude or the coordinates should be 6 decimal places. 4 decimal places means there are tendencies of error by tenths of meters. So 11 or 20 meters or 30 meters, not 100 meters, but tenths of meters. Okay. Let me show you okay, all right. Here, this decimal degrees, we call the arrangement of the coordinates as decimal degrees. There are many others. So in terms of decimal degrees, as we can see in our data here, sorry, this one. Okay, 5.1444 144. This is a decimal degree. Okay. If degree, minute, second, they have this other units. Okay, degree, minutes, and seconds. But decimal degrees only have the decimal point, of course. So as in our case, the data is only have 4 decimal places. All right, these 4 decimal places is actually have a tendencies of error by tenths of a meter. Okay, here by tenths of a meter. So if you want to collect the data, the coordinates, please have 6 decimal places, or at least in your case 5 decimal places, because it will contribute to error. Okay, so if this data is yours and you have 4 decimal places instead of 5 or 6, 6 is the best. If you have 4 decimal places, then there are ways in order for you to get the coordinates back. You can simply go to Google Map. Actually, Google Map have improved its coordinates. In order for you to obtain the coordinates, it has improved. Let's say your coordinates, it only has 4 decimal places, while the requirement is 5 or 6. Okay, but you remember the locations of the data being collected. Okay, because you yourself collect the data, so you remember where is the positions of station 1, station number 2. All right, let's say this is our School of Civil Engineering. Let's say you have collected one point at around this school. Let's say on this particular point, you can scroll it, zoom it even closer, and then simply right click it and click this one. This one got what? 1 2 3 4 5. 1 2 3 4 5. It's good enough. It's good enough. But the best is 6 decimal places. So how to obtain 6 decimal places is you select this one. What's here? Okay. What's here will give you 1 2 3 4 5 6 decimal places. Okay, sorry. So if you click what's here, okay. Hold up. Okay, this is another improvement of the Google Map. So may I suggest another software is called as Google Earth. Okay, Google Earth, where you can simply obtain the coordinates, all right, simply by using this place mark. Okay, place mark right here. Okay, let's say we zoom in into Pulau Pinang. Okay, to our school. I don't know whether perhaps here. Okay, here. Okay, and then you can simply use this place mark and then place it on the position that you have collected the data. Okay, now you will have the coordinates in 6 decimal places, which is very good. Although recommended is good enough to have 5, but 6 is very good. So now I just realized this Google Map has actually updates a few things. The first thing is this one. All right, the second thing is if you click what's here, it will move to the closest point of interest. So it's not good. All right, so simply click what's here. 14693. Let's say if I move a little bit to the left, 14692, which is very accurate enough. Okay, it's accurate enough. So simply right click and left click this one. Right, and it has been copied to the clipboard. Then you can paste it like so. Wow, now this is new. So okay, you don't have any problem in terms of coordinates because it will give you many decimal places. Now the things that you need to think of is how to reduce the coordinates until 6 decimal places. Okay, so the thing is, right click, left click, copy it, and then go to your Excel and paste it. There you go, as simple as that. Okay, wow. Right, but the next thing you need to do here is to separate it. Okay, you can simply go to data, go to, sorry, data, is it review? Okay, text to column. Okay, data, text to column, and then choose delimited, next, use comma. Okay, and then click next and finish. All right, now it will separate into this latitude and longitude, and you can set this number of decimal places into just 6 decimal places. Okay, simply by using this one. Okay, this one, this. All right, like so. That is how you obtain your coordinates if you have 4 decimal places right here. But as for this case, we just have 4 decimal places, then we simply use it. Okay, we simply use this data, but later in your case, please make sure that at least to have 5 decimal places, if not 6. 6 is the best. All right, don't forget to close it, don't save. All right, that is how you obtain the coordinates if you have trouble in your own coordinate. All right, next we will start with the first one, which is the art catalog. Is there any questions that you would like to ask? All right, so you can either focus on how I'm doing it and watch the recorded, or you can follow together with me. Okay, so first of all, go to ArcGIS art catalog. Okay, art catalog is a part of ArcGIS where it deals with the connection to your working folder. It is good for you to have a working folder. Okay, always have a working folder. So the working folder need to be stored in other drive other than C. Okay, don't store your data, all the data in C drive or in the desktop, because it will create lagging to your system. Okay, so let's say I'm going to create my working folder, ArcGIS noise work folder. Let's say that's the name. Okay, and then simply copy this data and paste it into this folder. All right, whatever data after this, the results, okay, satellite data or whatnot, okay, we will store it in our working folder. Okay, so the first thing you need to do is to connect the system, this ArcGIS, to your working folder. Right, as in my case, I have a lot of working folder already. So the buttons is right here on the top left, connect to folder, and then go to drive D, this PC, drive D, and look for the working folder. Okay, as in my case, ArcGIS noise work folder here. Okay, once I connected to this folder, then our catalog will show to me whatever data that have in it. Okay. All right, there are nothing much regarding the metadata, the data of the data itself. There are nothing much because this is we just created this data, nothing else. So once you have connected to this working folder, you may close it, or you can either just minimize it. Okay, next, to open the ArcMap. Okay, simply open this ArcMap. ArcMap, of course, as I mentioned before, it is for to do the analysis, to do some data editing, manipulation of the data. Everything will happen in ArcMap. Okay. All right. First of all, please, once you open it, save it to your working folder and give it a name. All right. Nice map. That's so. Save. All right. Whatever you do, the analysis or whatnot, please save it. Okay. So the first step, once we have connected to our working folder, we have to add the data that we want to process. Okay. So I'm looking for my working folder just now. Okay, this one, ArcGIS noise work folder. And of course, I can see the Excel data. Double click it. Alright, now it's stated failed to connect to database. This is what I'm talking about previously. So the format is not suitable. Sometimes I'm not sure. Sometimes it's okay with this format. So what we need to do in order to solve this problem is go back to our working folder, of course. Open the data back. Sorry. All right. If you cannot open like this, of course, just delete this one. Okay, because it has been inserted into an ArcMap, but ArcMap doesn't understand it. So delete that one. Then open it back. Still, Excel cannot open the file noise because the file from extension is not valid. Alright, this is a good example actually for you to always have a backup data. Before you do any analysis, please do a backup data. Alright, okay. As in this case, I believe I need to close this one. Try to open it back. Alright, so actually the file has been connected to ArcCatalog, and just now I opened this file through ArcCatalog and tried to look for the metadata. So that is the case. I couldn't open it afterwards. So all I need to do is to close the ArcCatalog, and then yes, I can access this file. So back to our problem. Alright, the ArcMap doesn't recognize this type of files for some reason. Sometimes it recognizes, I don't know why, but save it into 97-2003 SLS. Okay, save it in this format. Okay, give another name, perhaps 2. Alright, save. Alright, So this is more recent. This is the one that ArcMap couldn't understand, and this one is the late one. All right, let us try to add the data back. All right, number 2, double click, yeah, problem solved, and then I simply click this sheet and then add. All right, nothing happened. It's actually something happened already. So as you can see, previously we looked at this drawing order. All right, list by drawing order on the top left here. My cursor is right here on top left. Now the table contents focus on list by source. So this is the file that we just uploaded. All right, next thing you need to do is right click the sheet and then display XY data. All right, so now ArcGIS has automatically detect which field is X, which field is Y. All right, so X field is the longitude. Of course, the longitude is the horizontal line, while the Y field is the vertical line, the latitude. All right, let me show you one image for you to better understand it. Desktop. Okay. All right, this is the thing. The one that goes up from the equator is a 0 latitude, right? Because the equator is the middle section, middle line of that separates north and south. So the equator is 0 latitude, while from the prime meridian is a 0 longitude, right? You just imagine it as a thing that swipe from left to right, this prime meridian swiping from left to right, while the equator is swiping from north to south. Okay, it can move. So the latitude will move up, and then the prime meridian, which is the represents the longitude, will move to the left. Okay, pinpointing at these particular locations. So similarly, X field is the longitude, the horizontal, while field is the latitude, the vertical. Okay. Next is to identify the coordinate system of input coordinates. The coordinate system, as you can see here in our data, is a decimal coordinates, or the coordinates obtained from the Google Map. Okay. The coordinate used by Google Map is actually standardized worldwide, which is called as WGS 84. So how to find it? There are many coordinate systems. First, go to edit. Again, go to edit. Okay, and then choose geographic coordinate system. Scroll down, go to world coordinate system. Scroll down even more, select WGS 1984. Okay, this is the coordinate system used by Google Map. Okay, so just click OK, and then again OK. So now this thing will appear. Okay, just to create the object ID. This is the ID that understandable in ArcMap. So ArcMap will create it automatically. All right, simply click OK, and this is the distributions of the points. All right, these are the distributions of the points as seen in our the Excel. All right. Sorry. If you want to take a look at the data, you can simply right click this one and go to open attribute table. So if you want to see the attributes, so these are the attributes. Okay, there are 35 points altogether with and each points have these informations, the latitude, longitude, this and everything. Okay, so this is the distributions, but the uploading process of your data is not completed yet. The next step is to right click it again, go to data and export the data. Okay, right click data, export data, and make sure that this is in the form of shp dot shp, and of course click it, find your working folder. Please always spend some time to save it in your working folder. If you have many working folder, please spend some time. Perhaps create a new folder and then write it as data. Yeah. Okay, so what's this data represent is a sampling point. Okay, sampling point. Save and then okay. So do you want to add the exported data in a map as a layer? Yes, because this is every data that have these events means it is a floating data. A floating data, it doesn't really actually save it in your working folder as a data. It's actually a floating, waiting for you whether you want to save it or you want to just look at it and then you don't want to save it. All right, so in this case we may remove this data. Okay, of course it will have the same attributes as shown previously in the floating data. Okay, so I hope up until this you can follow me in doing this, or at least you jot down the procedure. Okay, so next is to look at where does this data is actually distributed. Okay, first and foremost, I would like to discuss a bit about this data. All right, when you do a data collections, especially in noise mapping, please distribute the data evenly. Okay, roughly it looks well even. Okay, it's a good distribution, but except for these 2 points. Okay, except for these 2 points, it is too close actually. Okay, perhaps you can make it here if this is not a lake or something which is inaccessible. So perhaps you need to take the point right here. Okay, so you need to plan in the first hand on where to collect the data. Okay, next is to look at where does this located. Go to add base map. All right, add base map here. But if you don't have this tool, if your ArcGIS were not connected to ArcGIS, okay, this will be in a gray color. What you need to do is to connect to the internet. Of course, simply connect to your internet and then go to this icon, ArcGIS. All right, go to this icon and then run connection test or test connection now. Simply do like so, and then hopefully it will solve the problems of unable to access this base map. But that is how you connect to the server of ArcGIS Online. Okay. All right. Let's add the base map. Okay. There are many base map. Of course, it depends on you on what type of base map you want to use it. But usually people will use this imagery, not imagery with labels, but just a blank image. Okay. And click add. It depends on your internet connections. If your internet connection is good and your GPU or graphic card is good, and your RAM is high enough, let's say 8 gigabytes is high enough, is good enough, then it will appear more faster. So as in my case, I believe this is due to my internet connections. Okay, so this is the area, but I couldn't see the distribution of points. So now we need to change it a bit. Perhaps the color, all right, the color and size of the points. So what you need to do is double click this one, or single click this point here, and then go to a more contra in color, different color, let's say yellow, and then about the size, make it bigger. Okay, now you can see the distribution of points, but let's say make it even more bigger, 10. All right, so this is the distributions of the data that were collected. All right, between these 2 points, let's take a look. Between these 2 points, yeah, my internet connections. Okay, between these 2 points, I believe it doesn't has any barrier between these two, right? It doesn't has any wall between these two that you need to take it too closely, right? Because this one is considered too close uh, uh, as compared to, in this case, which is the study area is quite huge. All right. Okay. Again, the processing of the base map. I hope you guys don't have the. I hope you guys have a good connections, internet connections. All right. So let's talk about on how to represent the data. Okay. So how to represent the data, how to analyze the data. Okay, the most widely used analysis for noise mapping is actually called as interpolations. There are many types of interpolations available in ArcGIS. So every analysis, as I mentioned before, you can access it through this Arc toolbox. If it doesn't appear on this side, of course, it is actually on this menu. All right. As I mentioned before, the most commonly used tools is the spatial analysis tools here. So let's look at the interpolations. Interpolation is right here. IDW, kriging, natural neighbor. All right, these are the 3 widely used interpolations. But as for these 3, and this one I believe is to be the oldest, the inverse distance weighting analysis. Okay, but what type of data that you want to analyze? Either this one, this and this and this, or everything else. Okay, like so. So the 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 analysis allows you to choose actually one by one, whether you want to analyze it one by one, or you simply want to analyze it all at once. All right. If you want to analyze all at once, simply right click this tool and then go to batch. All right. All right. And this batch, I just quickly go through. You can add the rows based on the data that you want to analyze. Okay. So one row represent one data. As in this case, I want to show you the you need to get familiarized with processing it one by one before you can process it in a batch. Okay, so this is um, one processing at a time technique. So input point features, you can either click this drop down menu, or if you have too many data already, you can simply drag and drop. Okay, drag and drop. Okay, and the z value field. Okay, the z value field, this is the field that you need to choose what types of data that you want to process. Okay, let's say I want to process LEQ at LEQ right here. Let's say this is the first data, and then for the output raster, I will navigate it back to my working folder. So ArcGIS noise work folder here. Go to data and give it a name. So as in this case, LEQ IDW. Okay, IDW. So the data and what sort of analysis that I'm currently doing. Okay. Save the output cell size. You can change it, of course, but highly recommended that you just as in this basic processing, you just take the default. Okay, and the next one is number of points to analyze the interactions between one another. Number of points by default is 12, so it will count the neighboring points until 12 points, and then it will do the analysis, and from this point it will find another 12 points, do the analysis from this point also, from this point also. So by the end of the processing, it will touch all the 12 points. Okay, each point will touch all the neighboring 12 points. Or either you can change it, you can analyze it by distance. All right, if you already know the interval, if the interval is fixed from one to another, let's say 3 kilometers or 1 kilometers perhaps. Okay, you can put it here. 1 kilometer means 1000 meter, you can type it 1000. Okay, so that is how you do the process, do the settings right here in order to run the IDW process. Okay, so now I'm going to simply click OK. All right, the analysis should begin. Yeah, something wrong. Okay, let's take a look. What's the matter? So the output raster still empty, the environment, the message. Okay, error for grid ID. Okay, all right. This is the things where you need to go to customize, go to extension. You need to activate the tools first. All right. As in my case, I already activated. Okay. Go to customize extension. Of course, you need to activate the tools first before doing any analysis. Go to toolbar. No, nothing. Alright, let's run it again. Writing raster, error in executing grid expression. Okay, whatever it is, if you find any error here, okay, you can always Google it to find the answer. Alright, as in my case, I will try to do it again. Sampling point, LEQ. LEQ. Raster data, save. Power, no, there is no. Nothing. Okay. We try to run it again. Let's take a look. Still not running. Alright. Now I just save it. Save this file and close, and of course open it back. Actually, this might work because this is one of the way to restart everything. Okay, let's just wait. Okay, let me close the base map first. Perhaps it's interrupt my processing. Perhaps, I don't know. Go to toolbox, spatial analysis, interpolation, IDW. Okay, drag and drop. Go to LEQ, small data, right here. Okay, everything's good. LEQ, IDW, LEQ, IDW. Still not working. All right. Okay. All right. This might be because of art catalog problem. Sometimes, I'm not sure, because sometimes it happens in an easier way. Sometimes it needs some other sort of specific way. So in order to store this data, so what you need to do is open back the art catalog. Okay, go to your working folder, the data. Okay, the sampling point is right here. Now what you need to do is right click this right click this data folder, go to new, and then go to personal geodatabase. Okay, personal geodatabase, might solve the problem. And also you can store everything inside here instead of just a folder. All right, a typical folder. So this one is, let's say we put it as results. Okay, and then I close it. All right, now I will run the process again. You can either choose it like so, or simply go to result. Okay, and then double click it. All right, it will generate whatever settings that you have done before. So as in this case, the problem is, I hope so, the problem is because I'm saving it in a typical folder. Now I'm going to save it in personal geodatabase. So right click personal geodatabase results, and then LEQ IDW, save. Okay, everything by default hopefully will solve the problem. Now it's running. Okay, now it solved the problem. Okay, so if you face the same problem as mine just now, all you need to do is to create a personal geodatabase. Okay, all right. So this image, this result is actually explaining the 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 intensity of noise between the points. Okay, between these 2 points. All right. Uh, Perhaps this one is in green color like so. Okay, it's very low in decibel. All right. Whereas if you move for what, about a kilometer long, as you can see in this part, okay, in this small box, if you move just less than a kilometer, then the noise will increase. So these are the things that the interpolations are capable of, the inverse distance weighting. Okay, let's close it. Okay, choose a normal cursor, right, like so. Okay, now if you want to do some changes regarding the combination of colors, you can always do it here. Right click, go to properties, of course right click the results. Okay, this is the results layer. Go to properties, go to symbology. So this is where you can reclassify the range of decibel. Perhaps you may find it in EIA report, a previous EIA report, or in a what we call this, in a standards or guidelines. All right, you can find the proper range of noise. Okay, whether it is acceptable or not acceptable. Okay, so as in this case, they are divided into 9 classes with equal interval. All right, you may choose the natural breaks. All right, they have several algorithms right here, or equations right here, which will analyze the distribution of the noise. Okay, it depends on you which one is suitable. Usually people will go for manual and insert it manually, of course, or reduce the number of classes. Let's say 5 class, where 0 to 1 is the least an acceptable amount of noise. 4 to 5 is the highest, okay, amount of noise, perhaps. Okay, of course the break values, you can either choose percentage, or you can also choose the all right. If I click it, it goes to percentage. So this one is, I believe, percentage, and this one is not a percentage. This one is just a value. You can change it yourself. Perhaps the highest is 100, and then 80, 60. Okay, I just type it. 40 and 20. Let's say. Okay. The lowest it can go is 46. It's not 20. Okay. All right. So and then you can also change the color combinations, like so. Perhaps red and blue, or red and green. Okay, red and green. So the red should represent the highest decibel. So you can right click the symbol right here, or left click, sorry, left click and flip colors. Okay, flip colors, and then simply click apply, and there you go. All right, not even one goes to up to 100 decibels, but it's just a range between 60, yeah, between this class and this class. All right. All right. uh, Perhaps you can change it in this label. Okay. Class 1, or class 2. Okay, class 3, class 4, class 5. Class 5 is the worst class. All right, let's see. Or play around, increase the number of classes, so it will be better. It will looks better, but whether it be better or not, it depends on you. Okay. Classified, you can this is classified. You can also go for stretch. All right, stretch is much smoother because it doesn't deals with classes. So if you choose the same colors, like so. All right, can we flip it? Yeah, there actually a way to flip these colors. Just click apply. All right, so as you can see here, actually the red one is the low noise. Just change the color again. All right, from yellow to red. All right, the yellow is the low noise, while the red is the much higher decibel, much higher noise. Okay, so this is how you stretch the interpolation, or you can use the classified, where you put it into a range of classes. Okay, like so. Let's say. Okay, but let's go to the next on how to beautify your map representation, because this is just a square study area. Okay, it doesn't represent any states, any mukims, or any uh, uh, I'm not sure what we call this in English. Your study area. Okay, as simple as that. It doesn't show your exact study area. Okay. For example, the data right here, you have the data right here, but you don't have the data on this side. Okay, so this is not a very good representation. If you want to present this as a map, all you need to do is turn on your base map back. All right, and perhaps just turn off this one. All right, let's take a look at the study area. Okay, so this is the study area, where it is good for you to have at least a buffer of a kilometer. Okay, a buffer of a kilometer away from the the last points, like so. Okay, away from the last points, like so. At least you need to have a buffer of kilometer, or in case of a bigger study area, perhaps in a state level, okay, um, or in a city level, all right, you need to digitize the border of the city or the state or the regional. Okay, so this case, which is located, oh, all right, this is our campus. So in this case, we don't need the noise uh, on this left side, on this on the sea. All right, we just need on the residential part here, where the populated area. Okay, so this is the next agenda in our discussions, where we are trying to digitize a map. We are trying to digitize a border, okay, of this map. So how to do it? First of all, you need to go back to your art catalog, ArcGIS, art catalog. Okay, in your working folder, okay, right click the data, go to new, and then go to shapefile. Shapefile is actually a very common GIS file. If you talk about GIS, you should know shapefiles. Okay. So the name of the shapefile will be boundary study area, and the feature type should be in a polygon. All right. The one, okay, let me close it first. The one that shows here, the sampling point is point feature type. Okay. If happens to be I need to digitize a line, let's say this road, okay, like so. This is what we call as a line shapefile, okay, polyline shapefile, polyline. If happens to be I want to make it as a polygon, I want to make it a loop, right? This is what we call is as uh, a polygon. All right, as in our case, we want to create a boundary of our study area, then the shapefile should be polygon. All right, so the name, what I said before, the boundary of the study area. Okay, feature type, choose polygon. All right, the other two is seldomly used. Okay, just between these three, choose polygon, and of course the coordinate system must be similar to the one that you registered, the sampling point, right? As in this case, WGS 1984, or you can simply type it here, WGS 1984, okay, and make it as a your favorite coordinates. All right, click it, okay, and then okay. So what happened here is actually you have created a blank shapefile. Okay, simply click add, go back a few steps. Here, boundary study area. Okay, and click add. Okay, so this is the file which is blue in color. Now we are going to learn on how to digitize the study area. Okay, I will make it in a simple box. Okay, so go to customize toolbar and choose editor toolbar. Okay, editor toolbar is used for what we call this, editing. Okay, so this is the bar editor. start editing. You can either start it like so, editor, start editing, or right click here, edit features, start editing. Okay, there are two ways. Okay, now as you can see here, the cursor has changed in shapes. That means this cursor means the editor has been started. Okay, so what you need to do next is to open the editor pane, P-A-N-E. Okay, sketch properties, attributes, this one, create feature. Okay, click it, create features, and you will see two shapefile layers that is ready for editing. So move it here or close it. No. Okay, so as in this case, we are going to edit the boundary. So we choose this one. Okay, boundary area, polygon. Of course, it provides also in terms of a preset shapes, rectangle, circle, or freehand, but we choose polygon. Okay, and then you can see again the cursor has changed to like a crosshair. Okay, this is where you can start digitizing the boundary of your study area. So I'm just zoom in and zoom out. Okay, like so. All right. Simply left click and drag, and left click, move, move like so. Okay, to digitize it. So if you face this end of a river or the downstream where it meets the sea, I forgot the name of these features. All right, you can simply jump it. All right, just jump. All right, okay, like so. There are many tributaries for this river that flows to the sea. Okay, from this point, can go straight. Let me take one or two. Okay. Go straight to the right. Make it flat. Top. Flat like so. Alright. Right click and finish your sketch, or simply click F2. The hotkey. Alright, click finish sketch. So this is the results of your polygon digitize. Okay, of course, if you want to see the attribute, right click, go to open attribute. This is the first feature ID. FID means feature ID. Okay, if you don't like it, of course, you can simply delete the selected layer. Okay, but it's in my case, yeah, I'm quite satisfied. And then go to editor, stop editing, or perhaps save edits first and stop editing. If you haven't saved it first and then you directly click stop editing, the ArcGIS ArcMap will ask you on whether you want to save it or not. Okay, so don't worry on that part. Okay, so this is my study area, let's say. All right, next, how do I convert between these? Okay, let me close it first. I'll bring it top. Okay, how do I want to change this into this new boundary? Okay, so the only way is to run the analysis again. All right, go to results, double click, the same name. That's why they ask you to change. Okay, simply do like so. The second one, save. Sometimes there are limitations on the number of words or alphabets that you can put it in the name. All right. Usually the maximum will be 13 alphabets only. Okay, so the 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 steps actually continue with selecting the environment. All right, not by simply click OK. If you click OK right now, it will be as the same as this one. But now we just simply go for environment. Okay, and then click the processing extend. By default, you choose the boundary of the study area. Same as layer boundary study area. Okay, and snap to raster. No need to snap to raster. Okay, click OK. All right, and then click OK, like so. Yeah, some trouble again. Always a trouble. Don't want to solve it. Okay, so the boundary area, let's say, okay, firstly I remove this one, remove on this art map, and I just reposition it. Can it? Right click, copy. Oh, okay, so this is not the problem. Let me run it again. Just want to run it again. Add the data boundary. Okay, perhaps I save it outside. Save the data outside. No. I need to save it inside. Environment, processing extend, same as boundary. Okay. There's nothing wrong actually. Okay, don't forget to save it, of course. Let me try the cheapest debugging, all right, method. In some cases, during my PhD work, I simply restart my PC and then, yeah, the ArcGIS can process everything back like a normal. Again, let me take a look. Properties. The source is the same. Okay, should be okay. How about I start it all over again instead of instead of continue from the last word. So the z value should be leq. I'm going to store it in my personal geodatabase leq with boundary environment processing extent. Go to the boundary study area. Okay. Okay. Well, I'm not expecting like this. Let me try to run it again. So, so the new things that we learned right here is actually if you want to process something else, as in this case something new which deals with a boundary, a new boundary, you need to start all over again from fresh, not through this result. Okay. Yeah, I'll try again. Okay, z value leq boundary, so boundary number 2, variable, everything, go processing extent, go to boundary study area, snap raster. No, I don't want to snap raster. Okay, no problem. There actually, as in my experience, I'm sorry which version I'm using it or other software. But there is actually a snap, not a snap raster, but actually snap to polygon tools. Okay, snap to polygon tools, which you need to tick it. All right, tick the box. So the process output will automatically follow the boundary of this study area. But this is also good, where I can show you on how to turn this box into this blue polygon. Okay, so the step is go to toolbox, go to analysis tools, all right, extract and click. Okay, all right, extract and click. Okay. This is the clipping. Let's say you have a puncher, you want to punch your paper. All right, once you punch your paper, you will have the result of a circle paper. All right, if your puncher shapes like a circle, then you will have a circle. If you have a puncher shape as a star, then you have a paper punch as in star shape. So this is the clipping function. There are many clipping functions available. As in this case, I show to you is the between two vector layers. Let's go through what is the meaning of vector. Vector is actually like this polygon, the blue one, where if you zoom it, close the base map. If you zoom it, it will look as though as you were not zooming in. Okay, so it is like an AutoCAD. I am sure you are familiar with AutoCAD. Whether you zoom it 100 times, you will just see the lines, not as a pixel. So whatever things that deals with a vector, you will not see the pixel, sorry. But if um, there is a raster layer like this one is called as raster layer. Okay, when you zoom even further, you can actually you can see the pixels. This is actually in a pixels form. This is a raster layer. Okay, yeah, as you can see here, that there is a crooked actually. All right, crooked part here and there. This one is a raster layer. So the clipping process between a raster and a vector layer requires a special tools, not these tools. It requires other tools. You can simply go to data management tools, go to raster processing, and then this clip. All right, this is the clip that we are looking for. All right, let's say you know the name of the tools, but you don't know where to find it. Okay, you can go to customize. No, not customize. You go to Windows and search Control F. All right, Control F. Or in my case, I've already pinned it on the side. All right, you can simply type clip and then search for it. All right, so there are many tools that similar to clipping, or is the tools actually a clipping tools. So this one, the other one is the rest here is actually quite similar to clipping, but it is not actually clip. So this one, we have 3 different clipping tools, but as in my case, I already know this function. So raster processing, clip, double click this one, drag and drop this boundary. Okay, LEQ boundary, this one, the big one. Okay, the output as 10, choose the boundary study area, which is a vector, and then use input feature for clipping geometry. All right, click this one. All right, highlight this text, highlight this box. Then of course, give a new name, LEQ boundary clip, save. Okay, you don't need to open this environment in order to change the processing as 10, because you are not even processing things like the IDW interpolation. Now you just clip it. All right, simply click OK. All right, so this is the new clip following the boundary of this one, following the boundary at the vector boundary. All right, like so. All right, you zoom in. Yeah, now you can see the pixels, the image of the pixel here. This is one square. If you want to know the size of the pixel, click here, measure tools, from one side to another. Then you will have a pixels information. Okay, the one side length of the pixel is 42 meters. Okay, It depends on you. As in this study case is good enough because the study case is quite huge. If you lower the distance between, make the pixel smaller, let's say 10 meters by 10 meters, then you will you need to have a higher processing, a better RAM. Okay. Similarly, you can change the colors like so. Okay. If you have many classes, let's say you have 30 classes, please choose the higher combination of colors like this one. Okay. Don't choose like this one if you have many number of classes. All right, as in my case here, only 5 classes. I choose 3 to 5 combinations. 5 combinations. Okay, so that you can look, the colors can distinctly separate between one another. Okay, it's easier to view. So this is how you clip your study area. Okay, if you open back the base map, yeah, it will looks like this. Okay, following the boundary of the sea to land. Okay, but what if for mapping purposes, you want to label each and one of these points. Okay, right click, go to properties, go to sorry, to display this point, not the layer. All right, display this point. You right click the point, right click the point layer, go to properties and go to labels. Okay, all right, these labels, and then take this one, label feature in this layer. Okay, so what labels that you want to put inside, it depends. Perhaps the number, the station number. Okay, the point, the sampling point number. Okay, after you have choose the appropriate font and size, click apply, and then now you can see the distributions of the points by number. Okay, all right, so yeah, let me close this base map because it's interrupt the process. Okay, so point number 1, number 2, number 3, that's all. Okay, move like so. So this is the analysis that you need to do for ArcGIS analysis, of course. Next, we are going for the final part, which is to produce maps. So how to produce maps? Right. Okay. To produce maps, you need to change this view. Currently, follow my cursor. My cursor is right here. Okay. Currently, it is in data view. Okay, data view. We need to change it into a layout view. Okay. So click it. So this is the layout view. Okay. How to pan around or to zoom in or zoom out this layout, or to zoom in to zoom out the files right here, your layer. uh, it is pretty simple. You simply need to click this shift button. Okay, if you want to zoom in zoom out the whole diagram, you can simply scroll it. Okay, if you want to change the dimension of or the size of your data, click shift and then scroll it in or scroll it back and forth. All right. Similarly, if you want to pan it around by this view, click your scroll button. Okay, and then you can pan it the diagram around. But if you want to pan this your layer, shift and then click your scroll button. Okay, then you can move this your results. Okay, this is the final step where you need to insert your north arrows, the legends which explains the colors, and the scale bar, and anything that will help your end user to understand it better. Okay, everything features in this map will be available in this menu, insert menu. Okay, go to insert menu. If you want to add the title, of course, just select it. But the most important is the north arrow, legend, and the scale bar. This is the three crucial or three must-have things in your map. So as in this case, I selected the north arrow. So there are many types of north arrow available, but please make it suitable for your studies. If you are studying history, you are creating a historic kind of map, then you choose this one. Okay, but if you are creating a more to research kind of map, please make it simple and easily understand. Okay, as in this case, I'm choosing this type of north arrow. All right, enlarge it. Okay, and put it in a suitable place, like so. Okay, next, go to insert again, go to legend. So legend, as I mentioned before, is the things that will explain this combination of colors. So what to input in your legend is actually the LEQ boundary clip. Okay, LEQ boundary clip. It's not this sampling point. Okay, the sampling point you can put it aside out of your legend. Next, the legend title, of course, legend. If you want to explain it in other language, of course, you may use it. You may change it. Next, these are the colors of the legends. I just click next and finish. Okay, so this is the legends which represent the colors right here. As you can see here, there are we need to change the names, and there are high number of decimal places right here, which is not really required. Okay, let's change it. So go to layer, properties, symbology. Okay, and change this labeling. Okay, change this labeling, perhaps class 1, class 2, class 4, class 5. Of course, you need to change it in the label column. All right, and then click apply, and then it will change it here. And of course this one should be flip colors. Yeah, should be like so. Okay. How about the name? The name, you need to change it here. Name. Let me take a look. LEQ should be something decibel, right? I believe it should be like so. Yeah. Decibel in what? dBl, dBA. So simply go to general. Okay, once you have click this one, properties. If you want to change the name of the layer, properties, go to general, and then change it here. LEQ in the form of, I'm not sure, is it dBA? I hope it's correct. Then click apply. So the end users will know that it is measured in this unit. Okay. All right. Another thing that is crucial to add in a map is the scale bar. Okay, the scale bar. You can change the units from miles to kilometers. Simply go to properties, and in these units change from miles to where is kilometers? Kilometers right here. Okay, and then yeah, right. So click apply, and then click OK. You may change the size of the okay, the scale bar. Or if you want to make it even, I don't know, prettier. Okay, but if you have added the scale bar and then you want to change the units afterwards, simply right click and properties, and then you can access the units from here too. Okay. All right. Of course you can change also the number of divisions, the number of subdivisions, this one, and click OK. Yeah, like so. It will automatically calculate it for you, the range of this distance to the map. Okay, it will automatically calculate it for you. Of course, the other, as I mentioned before, the title of the map, LEQ in Nibong Tabal. Okay, you may change the font and everything. So if you want to look at a sample of maps, of course you can simply Google it. Okay, in order to make it as a guidance for you to create a good looking map. Okay. So if you want to change the data frame, okay, whether to make it in a landscape mode or in a what we call this, a portrait mode, you can change it here. Okay, and of course anything that you want to change, you can simply right click the data frame and go to properties. Okay, so I think that's all for our class today. Is there any questions that you would like to ask? Mm, let's go here. Is it this one? No, finish. Oh, okay. Just want to expand.
Okay,
Okay,
everyone.
everyone.
If you have
If you
any
have any
question, you may
question, you may
ask
ask
now.
now.
But if you
But
are
if you are
hungry
hungry
because
because
it
it
is
is lunchtime
already,
already,
you may
you
save
may
the
save the
question
question
later and you
later
can
and you
ask
can ask
directly
directly
to
to
Dr.
Dr.
Hakim, or you
Hakim,
can
or you can
WhatsApp me the
WhatsApp me the
question and I
question
will
and I
pass
will
to
pass
Dr.
to Dr.
Hakim.
Hakim.
I think
I
that is
think that
all
is
for
all
today's
for
class.
today's
Thank
class.
you
Thank
very
you
much,
very
Dr.
much,
Hakim,
Dr.
for
Hakim,
your
for your
kindness in
kindness in
teaching us
teaching us
on how to
on how
produce
to
nose
produce
map.
nose
Thank you
map.
for the
Thank you for the
commitment for
commitment
these
for
2
these
days of
2 days
this
of
week.
this week.
I
I
am
am
really
really
feel
feel
honored
honored
for
for
the
the
help that you
help
have
that you have
given to
given to
me and to
me
the
and to
rest of
the
the
rest of
class.
the class.
Okay, I think
Okay, I
that is
think that is
all. Is
all.
it
Is
okay
it
for
okay for
everyone?
everyone?
Chang,
Chang,
Faith.
Faith.
I think
I
Aiman
think
is not
Aiman
with
is not
us
with us
today.
today.
Maybe
Maybe
How
he
to turn this this
screen.
screen.
yes, this screen. I want to turn off my screen and you know.
Oh,
Oh,
okay.
stop sharing, is it this one?
Stop sharing.
Stop sharing.
Oh, okay.
Stop sharing.
Stop
So
sharing.
may I?
Atas tu.
All right.
Alright.
Alright.
Okay, I think
Okay, I
that is
think that is
all. We
all. We
will meet
will
again
meet
next
again
week.
next
Thank you,
week.
Dr.
Thank you,
Hakim.
Dr. Hakim.
Yes,
Alright,
my
thank you,
Right,
pleasure.
thank you,
everyone.
everyone.
Yes. Is there any questions in the chat? No. All right.
Oh.
Oh.
Okay, thank
Okay.
you,
Okay, thank you,
everyone.
everyone.
Thank you.
Bye.
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 Have a good
Bye.
lunch. Bye.
Assalamualaikum.
Assalamualaikum, and
Salam.
We meet
we
again
meet again
next week.
next week.
Yes. Pleasure.
Okay.
Okay,
Thank you, doctor.
Okay.
Okay, thank you.
Bye.
Bye.
Bye.